Now let's talk temperatures. So as you've learned before, we have 3 different temperature scales that float around: Fahrenheit, Celsius, and Kelvin. Kelvin is our international system unit. Celsius is what we use in most labs, and then Fahrenheit is what the US uses. All these are slightly different, but Celsius and Kelvin especially are a little bit more related. When I compare them this way, I can see where the relationships are. Okay, now Kelvin has what we call absolute zero, meaning that that's it, doesn't go any lower than that. So you will never get a negative Kelvin temperature. We can get negative Fahrenheit temperatures, we can get negative Celsius temperatures. We will never get a negative Kelvin temperature. Now on the Celsius scale, water freezes at 0 degrees. Very easy to remember. Water boils at 100 degrees. Kelvin, we have 273 and 373. So if I do 373 minus 273, I get 100. If I do 100 minus 0, I get 100. The size of the degree in Celsius and Kelvin is exactly the same. The change in temperature, so if I have a Celsius temperature that goes from like 12 degrees to 15 degrees, okay, my change in temperature is 3 degrees. Well, because of the differences between Celsius and Kelvin are just additive, the degree size is the same, the change in Kelvin would also be only 3. But when I look at Fahrenheit, well, water freezes at 32 degrees Fahrenheit and boils at 212. That's 180 degree intervals. So the size of the degree is different. And so I can do an equivalency here, okay? 180 degrees Fahrenheit is equal to 100 degrees Celsius is equal to 100 Kelvin. All right. Now, previously you've learned formulas like 9/5 or 1.8 or 5/9. Well, that comes from putting 180 over 100. If I do 180 over 100, I get 1.8 or I get 9/5. Okay, or if I do 100 over 180, that's where I get 5/9. Those where those formulas come from. And then you either add or subtract 32 because there's the freezing point of Celsius is 0 and freezing point of Fahrenheit is that 32. So we're going to try a couple conversions where we're going to build the conversion instead of just using those formulas. Okay, so we're going to do a Celsius to Fahrenheit conversion and then a Fahrenheit to Celsius conversion. All right, so when I'm doing Celsius to Fahrenheit, okay, it's a 2-step process. Okay, so the order that we do Celsius to Fahrenheit is the first thing that we do is we convert the size of the degree. Okay, so I have 25 degrees Celsius, I have 180 Fahrenheit degrees for every 100 Celsius degrees. All right, so that gives me 45. Now, 25 degrees Celsius, is that above or below the Celsius freezing point? It's above. So when I convert the size of the degree, we are above our freezing point. So what this means is that previously we were 25 Celsius degrees above our freezing point. Here, when we convert the size of the degree, we are 45 Fahrenheit degrees above the freezing point. So 45 Fahrenheit degrees above our freezing point. Okay? So then our second step is we have to adjust for that freezing point. Okay? And so we're above the freezing point, so I'm going to do 45 degrees plus, what's the freezing point? 32. So our final Fahrenheit temperature is 77 degrees Fahrenheit. So I add to it that Fahrenheit freezing point. Okay? All right, now, when I go from Fahrenheit to Celsius, we're going to do it in the opposite order. Okay? So Fahrenheit to Celsius. Our first step for this one is to fix the 0 point. Which basically means adjust for the freezing point. That's all you're doing when you're fixing the 0 point. And it's called that because we end up getting 0 degrees Celsius for our freezing point. All right, so what we have is 25 degrees Fahrenheit is below okay, it's below freezing point by how many degrees? What's the difference between 25 and 7? I mean, 25, I just gave it away. 25 and 32, it's 7. So 25 degrees Fahrenheit is below the freezing point by 7 degrees Fahrenheit. Okay, so there's my fixing to the 0 point. All right, and then we're going to convert size of degree. Okay, 7 degrees Fahrenheit times 100 Celsius degrees for every 180 Fahrenheit degrees gives me, okay, and remember we were below the freezing point, so we were 3.9 degrees Celsius below. All right, and so I'm going to get negative 3.9 degrees Celsius. Okay, so that's how we go between our Fahrenheit and Celsius when we don't use those formulas. So what this means is we can do a completely fake conversion. So let's say we have this new temperature scale, the Stark temperature scale. Here, water freezes at 192 degrees Stark and boils at 777 degrees Stark. So we want to convert 36 degrees Celsius to degrees Stark. Okay, so if we have our thermometer here, so for our Stark, our freezing point, 192 versus 777 for the boiling point. And so our difference here, right, we have 585 degrees between those two. So Celsius, we know that the difference between the freezing point and the boiling point is 100. So we can say that 100 degrees Celsius is equal to 585 degrees Stark. Okay, now we're going to go from Celsius to Stark. So that's going to be just like going from Celsius to Fahrenheit. Okay. All right, so it's just like Celsius to Fahrenheit. So our degrees Celsius to degrees Stark, first, we're going to convert the size of the degree. So 36 degrees Celsius times 585 degrees Stark per every 100 degrees Celsius gives me 210.6. Okay, 36 degrees Celsius, is that above or below the freezing point? It's above, so we get 210 degrees, 210.6 degrees Stark above our freezing point. And so then we're going to adjust our freezing point, so 210.6 plus our freezing point, which in the Stark scale is 192, gives us 402.6 degrees. So that's how you can set up a temperature conversion between a completely different temperature scale and Celsius, or how you can do those conversions without just having to memorize those formulas, because that's what those formulas actually mean, is we're converting the size of the degree and we are adjusting for the freezing point.